Right, good morning, everyone. Right, today we want to look at mechanical drawing with focus on assembly drawing. Right, it's a revision task. Right, like I said, we are going to reserve our Saturdays for question 4 of paper 1 or paper 2. So we are going to look at assembly drawing today. Right, okay, I wanted to switch on to our content, but it looks like it is frozen on this page. But basically, with regards to this one, we are looking at assembly drawing. We are going to look at a past exam paper, right? It's a revision exercise, right? It's a past exam paper from Feb and March 2017 in terms of the national supplementary paper. Right, as always, right, I would have said those important words by Rotary. I hear and I forget, I see and I remember, I do and I understand. So we want to make sure that you are able to see whatever we are doing today in terms of the procedures, and you are also able to do exactly what we want you to do in terms of those procedures as well. So enjoy the lesson and all the best. Right, what you are looking at is the paper that we are going to use. It's our answer sheet, and we are also going to look at the question itself with regards to what is it that we are going to do today. Right, like I said, it's question number 4, mechanical assembly. Right, given orthographic views of the parts of a tension pulley assembly. Right, the exploded isometric drawing of parts of the tension pulley assembly showing the position of each part relative to all others. So we are given all this information with regards to the tension pulley assembly. Right, so that is the exploded view. When you are looking from this side, you are looking at the front view. When you are looking from that side, right, you will check, we are looking at the left view. Then, of course, if you are looking from this side, you are looking at the top view. Remember in paper 2, right, we basically make use of third angle orthographic projection. So if there is a top view, it has to be drawn at the top and in line with the front view. And if there is a left view, it has to be seen from the left and in line with the front view as well. So it will be directly in line with the front view. The top view is directly on top of the front view. Right, let's look at the instructions for this particular question. Answer this question on page 6. That is the one that I've shown you, which is at the bottom there, which is showing all the rubric and the mark allocation. Draw to scale 1:1 and in third angle orthographic projection the following views of the assembled parts of the tension pulley assembly. The front view is seen from the direction of the arrow shown on the exploded view. Like I said, when we are looking from this side, we are looking at the front view. A half sectional top view on cutting plane AA, right? So if we look at this, right, that is our cutting plane. It's going to cut like that, remove this part, okay? So whatever is shown, so if we cut like this, we are going to take this one away and throw. Whatever will be exposed thereafter, that's what we are going to remain with. But otherwise, the rest of the parts would remain in their outside view presentation. Right, show the front half in section, the front half, what it means. We are going to show this one, right? The front half of the top view, which is this part, which is that part, which is also that part as well, when we are looking at a pulley. Right, in accordance with the cutting plan that is shown on the left half of the housing, which is part 1. Right, okay, I think I've already shown you that. On the left view, sorry. Then we are also supposed to draw a left view, right? A left view, right? Note planning is essential, right? What we need when you hear, the moment you hear this word, essential, and it's about planning, you know you need to do what is referred to as space calculation. All drawings must comply with the guidelines contained in the Sense 10.111. The convention of symmetry may not be applied, but where you would find that you may need to draw half the given size so that you can use the convention of symmetry with regards to this particular exercise, it's not allowed. Show 3 faces with the M12 of the M12 nut in the top view. So in the top view, we would need to show the M12. So it should be positioned like this. At the cutting plane, no hidden detail is required. Right, all that has to be taken into consideration. And out of a paper of 200 marks, you'll find that you have 92 marks just for this question. So this is a major question. Right, so if we say 92 divided by 2, we are looking at the overall contribution as a percentage of this question to the whole paper. It's 46%, which is basically nearly 50% of the exam. So let us treat this question with the respect that it deserves. It's the major question with regards to paper 2. The same applies with paper 1, question number 4. Right, those 2 questions basically carry almost the same amount of marks. So how do we approach this one now? Right, what you need to do, first of all, you need to make sure that you are able to understand how the object would be represented, especially when it has to do with section. Right, now if we look at this, right, let's start with the pulley, okay? Right, remember we are going to cut the pulley halfway. What it means, we are going to cut and expose this part, right? So this line would now be the outline from here to there. It's outlined from here to there. It's outlined like that. The moment you outline a hidden detail, right, it would render this line to be thrown away. What it means is that this whole part here, right, when we are looking at the section of the pulley, so this part would be shown in section like that. It's important that you know exactly what you are supposed to do before you do that. Then the other thing, right, if we also cut here, right, like that, remember the cutting plane would pass through here like this, right? So this part is going to be exposed like this up to there, right? But we are not going to cut through the hidden detail, right? Right, because these ones are on this other side, okay? But we are cutting through here, so we'll cut like that, and we are going to cut through this part. Right, okay. We are not even going to cut through this wall because this one is here and that one is there. So we are going to expose this detail, which is that. Right, we are not going to expose that. This one, which is here, we are not going to expose that detail, right? It's not visible, right? Remember, the whole idea of creating a section is to expose the detail that you want to show. So we are going to hash from here to there. All this is going to be hashed up to the point of cutting like that. So when we look at the sectional top view with regards to the detail that has to be hashed, we are going to see something like this, right? This is where the pin would go through, right? Passing through that. Now, if we come here to the fork, right? Remember the cutting plane will do this like that. Then we expose this. We expose this one from here to there. We now remove this, and this one would now be, right, this line here would still be there, but we are going to expose that way. So the end result is that this one is going to be outlined, and we hash this part. Know exactly what you are going to do before you even do it, right? That would enhance. So we have got something like this. Then we also have got something like that. So that's what we are going to see with regards to, right, with regards to the fork, right? Is there any other detail, right? Now, if you look at this, right, this is a bush, right? How many of those bushes do we have? We've got two, right? The bush would get into the pulley. So you will take this bush and insert it there. Then the other one would come and be inserted from that end like that. Now, so if we take this bush, if we outline this, if we outline that like that, right, this part is also going to be hedged and slotted into the pulley. The other one would come from that side in terms of the pulley, right? Then the sub-assembly is placed between these arms of the fork, right? And that sub-assembly is now held in position by an M12 bolt, which is inserted from the left like that, getting through the bush and also through the pulley and secured on the other side by way of a washer and a nut. Right. Now we have got this one, which is our housing, right? The housing would be secured to the fork by way of a pin. We have got a pin there, right? The pin, right? We bring this one down in position to align with that wall. Then we take the pin, which is more like a dowel, then it is slotted in position like that. Right. So once you have understood how the components are going to be assembled together, the next thing that you need to know, right, is how am I going to place the views? We now go on to what we refer to as space calculation, okay? Right, if we look at this, right, we have got the pulley. The pulley is the diameter 60, right? But the pulley is also going to be assembled to the fork. So the distance from here to the center line of this one, this point is going to be right there. So what we need from here to the left, we need 30 millimeters, which is from here to there. Right, and we are also told that from this center to that point, which is the part here, right, which is also going to be aligned with the housing. So from here to there, we have got 30, right, which is the 34 for the pulley. Then from here to there, to that hollow part, we have got 105. So we are going to say in terms of the length that we require, length is equal to 30 plus 105 plus the distance that we have from here to there. Remember, 105 would end here, which is from here to there, and from here to that point, that's 105. From here to there, that's half of the 60, which is 30. So from this point to that point, we have got 20. So we have got the total length that we require is 155. Now we also look at the height, okay? We also look at the height. Before you start drawing, make sure you understand the space that you have, you understand the total size that you are going to accommodate on your paper, so that you don't run out of space during the course of your answering of this particular question. Right. Now, we said that we have got a pulley from the center going downwards, right? It's 30, right? So we are going to say 30 plus, right? Then if we take this one, this is the center line, and we bring this one, this part is going to be in line with that, right? But we have already taken if we take this one, it's 15 millimeters, and we know that the overall height is 75. So what it means from here to there is 60, right? So we are going to say 30 going down for the pulley and 60 going up from there, right? They share a same center. From the center line to the top, it's 60. From the center line to the bottom is 30. So we're going to say 30 plus 60. So our total height would be 90. But then the other thing that you would require is your total width. Right, if you look at this, from here to there, right, that's 40. From here to there, right, which is from here to there, that's 50. So you are going to write 50. That is the maximum in terms of the width. Once you have got all this information, right, you take your paper, you calculate, but before you calculate, we also need to measure the size of the paper. Right, we need to measure the size of the paper. Let me just do this. Right, okay. Right, from here to there, that's 210, which is this point. Then we add, we have got 95. So it's 210 plus 95, which is 305. Right, so we are going to say length of paper. Right, length of paper minus the width of the left view plus the length of the front view, right? Everything divided by 3, like that. So length of paper, we said is 305 minus the width, we said it's 50 plus the length, we said it's 155, everything divided by 3, so that we know how much space that we are going to use and where we are going to use that. So 305 minus 50 minus 155, it would give us that 100 divided by 3 spaces. Right, so we are going to have, right, in terms of the positioning of our drawings, we need to have a left view, we need to have, right, a front view, we also need to have, right, in line with this, we create a mitre line, like that. Right, so this is our top view, this is our front view, that's our left view. Right, okay. Right, so we are saying from here to there, that's 50. Right, we need space there, we need space there, we need space there. That's why we are saying divided by 50. Our space from here to there, that's 305 minus 50, space minus 105, not 105, 155 from here to there. Right, so 155 plus 1 plus 50 would get 205 being separated from 305. We ended up getting 33. So we are going to say this is 33, this is 33, this is 33 plus or minus, okay? All right, so that is the arrangement in terms of lengthwise of the paper. So let's measure that. We have got 33. We have got 50. Then 155. 33. Right, 33, 50, 33. Right, 155. You can actually see that we are left with roughly 33 on the other end. Right, then we draw feigned vertical lines going up. Right, that's 50. $33. So we've got this space, 50, space, 155, and space. Right. So we now have got the positioning in terms of our lengthwise. Right. Then we look at the height of the paper. Let me check. That's 210 plus 55. So the height of the paper is, so we say height of paper, remember we said height of paper is equals to 210 plus 55. That's 55. We get 265. That is the height of the paper. Height of paper minus, right, the width of the top view plus the height of the front view, right, everything divided by 3. What it means, basically, if we go back to our sketch, we need space there at the top, we need space in between, we need space at the bottom like that. Right here, that's 50, which is basically transferred from here to there in terms of the mitre line. Then we have got the height, which we said it's 90. So space 50, space 90, and space there. Right, okay. So if we are going to calculate this, we are going to say 265 minus, right, 50 plus 90, right, everything divided by 3. Let's do this. 265 minus 50 minus 90, you get 125 divided by 3, but we get about 41. So we are going to say 41, 50, 41, 90, and 41 plus or minus like this, from top to bottom or from bottom to top, whichever way. Right, so let's measure. Take this one down slightly. put 41. We put 50. 41. And 90. Like this. Draw faint lines. Like that. Right. As you can see, right, we now basically have got space with regards to where we are going to draw our views. All right, okay. This is where we are going to draw our top view. This is where we are going to draw our front view and our left view, like that. Right, if you are accurate, you'd find that you can easily draw the mitre line. Right, always the mitre line is drawn away from the front view. So we have our mitre line there. Right, now let us start, okay? Right. You start with the detail that is clear and obvious to draw, right? So if we are looking at the front view, right, the obvious detail that we will be able to see, right, would be the nut, right, followed by the washer, followed by the fork. So we need to draw the nut in position, but the moment you draw the nut in the front view, it should be drawn in the top view, it should be drawn in the left view as well. Right, okay, so let's do this. Right, I'm going to find the center, right? Remember we said 30 millimeters, like this. Currently, we draw that. And another 30 millimeters, we are not going to measure this. We can simply mitre like that. Then one other thing that is critical, when you are drawing in assembly, okay, make sure you draw the three views at once, right? You draw the three views at once. Right, now, if you are looking at this now, right, you'd find that in terms of our size, right, we mixed the size of the M12 bolt, which is actually 64. Right, now because we do have space that is available, right, we can then say 64 minus 50. Right, we have got 14 millimeters. Right, we have got 14 millimeters divided by 2. So either side we can add 7 millimeters in order to accommodate the M12 bolt, because that is the longest size, right? Because we had considered this one from here to there, right? But if you had not done space calculation, right, you would have used all the space or pushed one view on one side. So now that we have realized that this is the biggest size in terms of our width, right, we are going to add 64, right? But even if we don't add it now, okay? Even if we don't add that one now, right? When we consider the issue of the board in terms of the top view, in terms of the left view, right? You would realize that we would be able to extend it beyond these lines because we have got this space, we have got that space that is available. All right, okay. Now I also need to find the center line for this one, which is 25, like this. Take it to the mitre line. Planning is important in terms of drawing. All right, let us look at the nut that we talked about. But when we are looking from this side, we'll be able to see that one like that. Okay, that will be our top view. That will be our front view. All right. The same applies with the nut, with the washer. That will be our top view. That will be our front view. Right. Now we know that the washer is secured to the fork, as well as the bolt is also in contact with the fork, right? And the fork is in contact with the bush as well as the other bush on the other side, right? So what is the size of the fork? Right, in terms of the width, it's 40. So either side, we need to measure 20 and 20 so that we know where to position our washer. So we have got this, and we have got that as well. Right. We take this one to the mitre line. Just extend it slightly. Take this one to the mitre line. And we bring this one down. Let's send this thing. Like that. Right. So the washer would come and be drawn here, as well as the bolt head would also be drawn that side. Right, okay. Now here, that's where we would start our drawing. Right, it's M12, so we say 12 times 1.5, which will get 18 to get the chamber circle. Right, so we measure 9 millimeters as our radius. Like that. Then we draw our chamber circle. Right, okay. That's our chamber circle, right? Then we take this one here, like that, because this would be our flat, like that. On this side, we shall use that. Then we take our 60 degrees set square. We also create a flat this side and another one here. Do the same. We do the same. But once we have done that, we can outline this. Like that. Right, so we have got the nut in position with regards to the front view. Right, so that's our nut. Right, remember, the other thing that we also need is the washer. What is the size of the washer? It's diameter 24, which means the radius 12. So we need to measure 12 from here. We can outline this at once. It's not going to change. That is the washer in position. The moment we do this, we take it now, yeah, like that. We also take it there, like that. Right. So that's where the washer is going to be positioned. All right. Remember, we said from here to there, that's 40, right, which is the full extent of the fork. Right. Okay. Right. So the washer would come and be drawn here. Right. We also need to take this one up. Faintly. Like that. And we know that the washer in terms of the width is seen in the top view. Right. It's 2 millimeters. I'm going to measure this. So from here to there, we can outline that. That's for the washer. Right. Whether it is a section, we know that a washer would not be hedged, so we are going to define this one fully. Right. Now, what this means is that if you are looking right in the sectional top view, washer, you already have done that. Then we come here also washer, we have done that one as well. But if we come here, there's also a washer, you have done that. You have come, you go there, a washer is also in position. Right. Now we want to project, right, with regards to the left view. Right. If we are looking at the left view, we know that the nut is 10 millimeters. So we are going to measure from here to there. 10 millimeters, like that. Then we take this one up. We also need the same distance, but so we take it to the mitre line. But then this is what I was talking about. We can extend the mitre line now, since we have got enough space to maneuver. Right, then we also take this one like that. We don't need it all the way, right? Now, so from here to there, that's the height of the nut, which is that one. So we have got this point. You take your 30, 60 degree set square. Do this. You also do the same. This. Create a faint vertical line like that. But you stand here. And describe an arc. Right, you do the same from this point. Also describe an arc like that. Right, remember, if it is two-faced, they are not chambers, so you are going to outline from here to there, like that. You close this, and you also close that part. There you go. Right, so you have got a nut in the front view. You also have got a nut in the left view, but we are also going to create a nut there. So what we need, right, is to take this measurement or this point, take it up like that. There you go. Now, you have this point, you've got that point, you've got that point, and that point. You take your set square, right, the first one, all the way like this. Then you also come here, you describe that, change direction, right, you have got that. And you finish it off by doing this. Right, what we can do, raise this one slightly. Like that. So the first one, you stand here, open to that part. Then you describe. Then you reduce, you come and stand here. Do the same this side. It's like that. Right. So you stand here, describe an arc, stand there. Stand there, describe an arc. But you stand here, you also describe an arc like that. Right. The next thing that you want, right, you create these chambers, okay? Right, at 30 degrees. Right. You chamber this side and also chamber this side, but we can outline this. That's the chamber. under like that. Then we close. Do this. Like that. Right, so now we have got a fully defined nut. In the top view, we have got a fully defined nut in the left view, right, as well as a nut seen in the front view like this. Right. Once you have done that, the next thing that you would want now to do, what other detail would you require? Right, we can now position, right, draw this part, right, which is for the fork, which is radius 15. So I need to measure 15 from here. Right, 15, that's 15. Right, it's not going to change, so we can define that fully. Right, also take it to the left view, and also do the same, like that. Take the same detail also up. Like this. So we have got the position. If we check with regards to, the fork, from here to there, we are told it's 45. Let's define that. Right, from the center line to there, it's 45. And we take this one up. Right. Now, this part is not going to change with regards to your construction from here to there, right? Seeing the size from, in terms of this one from here to there, that's 65, right? Actually 65 minus 20, which means we need 40. So it's not going to change, it will be exposed. So we are going to outline this from here to there, like that. And also outline every detail that is clear to be defined, right? It should be defined fully. All right, okay. Now, we may also need, now we know that from here to there, that's the fork, okay? Right, and what is the size of the fork? Right, so from here to there it's 40, but from here to there is 30, which means either side is 5 millimeters, 5 millimeters, right? We can just measure 5, we mark like that. Also measure 5. That's correct, which is that. So I'm going to project this, right? And also do the same this side to there. Take this one up. Also take this one up like that. right? So in terms of our drawing, right, we know that the distance from here is not going to change, which is this part, as well as that part, okay? Right, that is the lower part of that, right? Then we also have got the same thing. If we take this one up like this, it's going to be this. That's the end, and that is the end part, okay? So that is the end of the fork, which is in contact with the washer. We also need to draw now the other part of the bolt, okay? Right, which should touch this end, right? And the bolt is, if we look at this, all right, from here to there, right, remember the bolt head would be in contact with the fork. So from here to that's 10, then we measure from the 10 coming to this side, we have got 64. All right, so let's measure 10 millimeters. We have got this part. Then we need 64, which is here. So we mark like that. So we connect to the miter line. And we take it down like that. Okay. Right. And what is the size? It's diameter 20. Right. So we need to measure from here to there. 10 and 10. Take this one up. Then there's a 2 millimeter in terms of the rounding. We can also do the same. Take it from here. Like that. But all details which can be projected should be projected like that. Now, once we have done that, right, we can now create the rounding at this point. Let's find the center and do the same this side. Find the center like that. We do this. But you take, because since it's too small, right? You take a circle template. Right, diameter 4, radius 2. Do the same. And we close this part. Take this. This part is not going to change because it's not going to be cut. So we can even outline this like that. We can miter here. And take this one down. We don't require it here, but we can project it like that. So from here to there, we can also outline. It's not going to change. because that is the detail that we are able to see when we are looking at the top. All right, so these are the lines that I've defined right now. But we can also take it from here to there. That part is not going to change either. Right. Now that we know the full extent, so what if we need the detail with regards to the board? Right, it's M12. So radius 6. Radius 6, like that. Right, it's an external thread. So we open to this. And we draw a circle like that. That is the nominal diameter, right? But once we have drawn this, you can now project it there. Project. Like this. We do the same. Also project like this. Then we need the thread depth is 12 times 0.1. But we get about 1.2, but which we can easily just measure 1 millimeter so that we can measure our thread. Right, okay. Standing at the center again, open to that. Then we draw an incomplete circle like this. Right. Then we project it up again. Project this one up. Maybe just to the center line like this. We know that in terms of our size, it's from here and to there, and from here to there. But we can chamfer this one now, chamfer it. Chamfer this and outline this. Like that. Close this. Like that. Close that. Close this one as well. Okay. Right. What we also need to check is the thread length. But from here to there, we need to measure 48. Right. It's from the end, so we measure 48. 48 would be somewhere here. Let's align with the center line. Right, it's exactly here. Right. Then here we draw a line like that. Then we outline this. When you are ending a thread, make sure you outline that. But we take this one right to the center because that's where it is supposed to be. So we are going to do this. When we stop there, we are also going to do this. Then we stop there, okay? Then we define the thread runout at 30 degrees, like this. So it's here. Okay. These threads can also be defined now. there. To there. So we have got the threads with regards to that. So we now have got a bolt, the washer, and the bolt, and a nut as well with regards to the top view. What it would mean, therefore, right here in terms of this part, we can also outline this. Can also outline this. Right, like that. Do the same this side. And all the way from here to there. So we are slowly building our assembly, right? Whatever we have done there, right? We can also project this one up to the left, to the left. Right, we need 20 millimeters. Right, create the centers for the rounding like that. Do the same this side. Like that. Remember that's from here to there is 20. That's the 20 that I have measured from here to there. It's like that. Just want to make sure you are able to see everything. Right, okay. Then once we've done that, create this, create that. Take a set of templates. Diameter 4, radius 2. Right. Now, if we check with regards to this one, we can see there's an opening here, okay? Right, the opening from here to there is 5 millimeters, right? And also the size of the opening itself, which we see from here to there, it's 4 millimeters, right? So we are going to measure 2 millimeters and another 2 millimeters here, like this. Then we'll do that. Then we need 5 millimeters from here. So it should be here. Okay. So we can outline this. Close this one. There you go. Right. So as much as we have got the bolt head this side, we also have got that this side as well. All right. Now we cannot see anything, right, with regards to that detail. Right. But what we'll be able to see, we'll see something beyond this. Let's wait and define the other details here. Right, well, let's project and we'll be able to see the threads as well, like the threads, We chamber this end. Chamber like that. Close. Outline this. Like that. Then we can write the red pen to show the thread depth like that. So we have got now the bolt in position, also shown this side. But remember the whole idea, whatever you do here should be done there as well, if you are dealing with 3 views. Right. Now, let's now go and provide other details. We are almost done. Right. If we look at this, right, we want to position this one where it is supposed to be. Right, so what we need to do is to measure from here to there 105. We measure 105, right, which is here. That's the center. That's the center. We take this one up like that. We know that the distance from here to there is 60 after taking 15 millimeters from here to there. But overall from here to there, that's 75. Right, but we've taken 15 millimeters on here. So then we need to establish the width. The width of the frame, we take it from there, it's 65. So we are going to measure 65 from here. And mark a point like that. Once we've marked, we project this one up like this. This is the point that we want, this is the point that we want. So we can even complete this one now, like that. And also come into the bottom and complete it as well. It's not going to change. Like this. We're not cutting it. Do this. There you go. Right. We also require this detail, right? We need this diameter 18, right? Diameter 18, so that we can draw tangential lines from this point and that point, from this point to that point, right? So let's measure 9, like that, and draw a faint circle. We are not outlining this, but once you have drawn those, we would need this information at the top. So we are going to project this up. It's just to the center line, because that is the exposed part, just to the center line like that. Right. Then from here, we now connect and draw tangential lines. Currently. Like this. Right. This is the detail that will be outlined with regards to the fork up to there. Up There you go. Right. They are also, if we are looking from the right, there is also this detail, which is the web. Right. We are told that it's from here to there. Right. It's 5 millimeters. So either side, let's measure 2.5, 2.5. It all the way, but we can just draw it like that. But what is required is this from here to there, from here to there. Now, the other thing that we will be able to see with regards to this detail, right? If we are looking at the housing, there is a diameter 10, right? Which would accommodate the diameter 10 pin. So we need to draw that because that is visible, right? So radius 5. Radius 5, like this. Stand here. And draw this. Sorry about that. Now, once we have done that, it happens when you are drawing small circles. We take this one up as well, we shall need it. Just halfway, we shall need that one as well. But I'm just going to illustrate this because we are going to draw a half section or something, right? That on this line, which is the halfway mark, we are going to draw sort of a center line like. This would define the point where we are cutting the object. Right, so everything which will be this side is going to be shown. Like here, we can as well, right, outline from here to there. But we need first of all to establish the size of the frame, but which should be 25 and 25, okay? Right, which is that? Let me just verify. Correct, okay. So there's nothing that will stop us. There's nothing that will stop us from doing this. So we are going to outline from here to there. We are also going to outline from here to there. Right, and also this part is going to be exposed. But it may not be the same size like that. So let's wait. This one is going to be exposed like that, we know, right? And also this one is going to be a complete thing. So we're going to do this, right? It's not going to change, right? The same applies with this. Looking at the size from here to there, it's on the other side. So from here to there, it's going to be exposed like that. There is nothing that would stop us from defining this. Right. Up to the point of cutting. Up to the point of cutting. Right. The same applies from here, right? There's nothing that would stop us from defining this. Right. So we have got that from here to there, from here to there. We shall provide those details before we conclude our diagram, okay? Right, if we follow this, all right, if we follow this, but we have got this point, and we also follow that, we also have got that. Let me just check. Right, that is the point, which is this one, as well as that one, which is here. Right. So in reality, we have got this distance up to that distance, which should be 50. Right. Exactly. Right. We can also do this outline here. But every detail that can be defined should be defined with, I think this one was slightly off. Outline this, and we see it partly at the bottom, okay? Remember, it's in line with that, okay? So we close this one like that. Right, the same applies with this one. Take it like that. Close it. This also needs to be closed there. We have got something like this. Right, so that's our housing in terms of what we'll be able to see. Right, when we are looking from this side, which is from the left-hand side, we are able to see this line from here to there, which is from here to there. Right, now this would run all the way downwards like that, except where we have got other parts which are interfering with that. Then the next thing that we want now to define is the issue of the pulley. Right. We know that the pulley is outside diameter 60, so which is this one, which is that one as well. So I'm going to outline this today. But here we need this construction so that we can project up like that. Once we have done that, we can take this one to the left. We can also, it's already there. Take this one up. Right. Before we define the pulley, there is also the bush in position. Right. This one. Right. The bush will get into the pulley. The bush will get into the pulley. We have got the pulley diameter, the inside diameter is diameter 20. But if we look at the outside diameter of the bush, but with regards to this part from here to there, right, it's diameter 28. So it's only this part that will get into the pulley. So the rest, which is from here to there, we are told that from here to there, that's 18, from here to there, that's 8. So 5 millimeters and 5 millimeters, that's our bush. Okay, so we are going to measure 5 and also 5 here. Like that. Right, we also need to measure 28. 15. 28 will be here. Which is 14, 28. Take this one. We cannot see the bush from the front view, so we are just going to localize this like that. Like that. Then we have got 5 millimeters. This we can take to the miter line. We can take this one to the miter line. That's for the bush. So this part can be defined like that. And this one also like that. That's the bush, okay? But on this side, it can be defined fully. But we would wait up until we are done with the pulley. Right. Then the next thing, right, we also need to define this. Right, so I'm going to project this one down. Align this like this. Okay. Right, we measure 28. This is our seam. We measure 28, which is 14. 14. Draw this. Also do the same this side, okay? Right, so what we want is this and that, which is also the same thing here. Right, let's just check something. Right, that's exactly that, because our pulley is 20 millimeters in terms of the width. This one can be close. That's 4. Right, that is for the fork. Right, we can take this one and close it here. Right, this will be extended. The same applies with this, will be extended. Right, so we have got our fork from here to there, which is the same as that one. We've got a bush, we've got a bush like that. Right, it's now in position. But we also need to define now. What we need to define is the pulley, okay? Right, with regards to the pulley, right, we know it would run all the way from here to there. It's not going to change, so we have got that. When it comes here, it will just be stopped by right, because we are exposing this, right? Let me just connect to here and there. Right, we'll need to define the bush getting into the pulley, okay? Right, the distance from here to there, that's 20. Right. Like this. That is the 5mm size with regards to the housing. So we'll take this one up. Take this one up like that. Right, let's look at the information with regards to the pulley. Right, we have from here to there, that's 12mm, and also from here to there, that's 6mm. So we need that info. Right, let's start with the 3mm. 3mm. 3mm like that. Take it to project it. Set point like this. Right, so from here to there, that's 6mm. Now we need the 12mm, which is 6 either side. From this point, which is there. Also take this one, the line. Take this one also to the 90 line. Take it down. So the next thing, we want to create an angle of 60 degrees, right? So we're going to do this. Just a little bit. Such that we have got our 6mm here. Okay. And also do the same this side. 6mm. Take this one to we can outline this. So that is our pulley in the top view. We are going to outline from here to there, like that. We are also going to outline from here to there, like that. Let me just extend this line of cutting. We are not going to outline anything here, but what we are going to do, we are going to define the size of the pulley. Right. In terms of its interaction with the bush, we know that the bush from here to there, that's 18. This one, 3, we mark. Do that. Then the outside diameter, that's diameter 20. So we need to measure this 10 and also 10 this side. And connect with this. Connect with that. Okay. But we said it's 13. Which is this, okay? So we are going to outline from here to there. From here to there. Right, okay, because the diameter from here to there, that should be 20, which is fine. Right. So we take this one, that is the open diameter for the pulley. Right. That's the open diameter for the pulley, like that. And the pulley would come here and there. Okay. Right. So the pulley is now extended today, and extended today. So this part, this one, and that one, they are basically our bushes in terms of, right. So from here, this part and that one, that's our bush. Right. Okay. Now the next thing that we want to define as well, right? Right, is the position. Let's look at this from this way. Right, we have got 40 here. Right, so we go to the center and we measure 20, 20, right, which is this part up to there. Right, like this, which is the same thing from there. Right, then we are also told that the distance from here to there is 5, 5. So that we know where this is landing. We have got 5. take this one to there. Also get coordinate. So this point is connected to this one. Right, let us so here we would connect this point to here, but we won't be able to see this detail like that. And you also do the same this side. Right. The end result is that this will be visible, but when we are looking at it from here, right, that will be visible. Right. And it will go all the way, right, all the way up until it is stopped by the pin. Right. We also need to miter here. Like that. And this one is brought. Right, if we look at this, when we are looking from the top, it's 5 millimeters. So half is not defined, but the other half is not cut. So we are going to say 2.5. Like this. The other half is going to be cut. So we project like that. And we also project like this. Right. This is going to be accommodated with, so it's from here to there, right? It's going to be one part. So outline here. And also outline here like this. Right, now we can go back here and define, which is our outline. We also outline from here to there. Right. This will be a web. So now define this one, which will be like this. Right, part of this web, right, it's not cut, so it's going to be illustrated like that. We also connect this one to there. There you go. Right, so in terms of our top view, right, it's slowly taking shape. Right, we have got the bush, so this part is going to be hedged, this part is all going to be hedged like that. Right, where you have got a solid part, you need like this. There you go. So in terms of our top view, right, that's the detail that we require. But what is left now is just to edge, okay? Right, let's go to this one. Right, in terms of our front view, our left view, right, we've got a measurement from here to there, which is 10, right? So it's 10 millimeters from here to there, but also the other part is radius 5. So from here to there, it should be 15. So we are going to measure 15. Which is this point. So we measure 15, sorry. We measure 15 from here to there. Right, and the width of that, if we check again, right, you will see that the width is 4 millimeters. So we take this one, we draw a faint horizontal line like that. We measure either side of that, 2 millimeters, 2 millimeters. And we have got 2 millimeters. We have got also 2 millimeters like this. Like that. Then this is incorporated into that part, which we are going to outline like this. Outline like that. Then we complete this one now by doing this. Right, then also the bottom part, but still we need to measure from the top, that's our center. This shape. Yes, from the top, that's our center line, which is that. Right, I'm going to use a different color for the center lines. Yes. Okay, so we have got our specific center line there. We also now require the details with regards to the pulley. So we are going to have this one at 60 degrees and also do the same this side. Right, like that, at 60 degrees. Like this. And this is connected, and also this one is connected to them. We have that. We have this. Let's connect to this one. And we can outline this. We do the same this side. We also can outline that. Do the same this side. We now can extend these lines all the way. That's that part. It's not going to be cut, so you can connect like this. There you go. Close this part. 6 millimeters. You close that part. That is the 6 millimeters as well. Right. Slowly but surely taking shape in terms of our diagram. All right, so the pulley is now in position here. We have got the bush, and the bush we have got the fork and the fork, the washer, the nut, and the bolt itself. So what we require now is to position, the spring, right? But remember they said you can position this one in such a way that, let me just bring this, show that there is in such a way that you have got its free hand. So I'm going to so we are going to do this from here like that. Then we take it down slightly, which is that. We go like this. Take it, take it, take it. Then you take it like that, but it's going to be hooked inside there, right? So we have got our convention in terms of the spring. Right. Remember the spring has got a center line, so I'm going to define this one like that. Okay. Right. With regards to the left view, but what is left is just to be able to see those walls which are on the frame. But these ones, they should be able to be seen. We need to measure from here to there, 40, right? And the position, right, relative to that, it's 24, which means center to center is 24. Okay. So let's measure 40 from here, from the bottom. There we go. Faint line like this. Right. The next thing from the center, we measure 12 millimeters, which is our center line. 12 millimeters, which is again our center line like that. Project this one up, project this one up. Right, what is the radius or the diameter of these circles? Diameter 8. But what we can do, we can make use of a circle template with regards to this. So look for 8, right, which is here. We have got our center lines. A line probably this. And we come here, we draw. What we do, go to the other side. We also do the same. So those are the holes that are able to be seen when you are looking from the left-hand side. Then the next thing is define the center lines. We also come here. We also have got a vertical center line. Okay. Also do this. That's a center line. But this one we've already defined like that. But if we check again, looking at the top view, but we have got this, we need 35. Right, 35 from here to there, then diameter 8 as well, okay? So we measure 35 here. Draw a faint vertical line, and from the center we need 12 millimeters. We mark that. And we take our circle template, diameter 8. Then we draw our circle like this. We can now define the center lines as well. So we have got the two center lines for that circular part. Right, that is it. Right, okay. We also have got the center line here. Like that. Right. The other thing that we also want to define is the issue of the cutting plane. Right, so they said we should position the cutting plane. Right, remember there are two ways that we can establish that cutting plane. A cutting plane is basically a center line. Right, okay, so we can come here like this, show a thick end line, right, like that. Then it should come all the way. So we show like that, the rest is there, right? Then a thick turn here, that is critical. Then we also show a thick end like that. This would be like this. Right. So if you are looking from the top, you would remove this part like that. Then it will expose the detail here. If you are looking from here, right, again, you will be able to see that with regards to the section like that. So this would be dependent on where you are looking at the direction. So we are going to say A like that, right? That's our cutting plane, right? Now let's do the hatching. Right, I'm going to start by hatching this, which is the fork. Let's take mine. Use a different color like this. This was, right? That is the part of the fork that has been cut. Right. Then the other part that also has been cut is this one. Let's alternate. There you go. Right. Now the next thing that we want is about the pulley. Then we alternate. Right. We now look at the bush. There you go. Right. So the bush, inside the pulley, we have got the fork. We also have got the housing as well. Right. Last but not least, we also need to define here. I've just noticed the center line like that. Remember, the center line can only be defined once you are done with the drawing. Right, there you go. Right, this is our exercise for today. Right, that's our exercise for today. Right, I hope you were able to get one or two things with regards to what we were doing today in terms of our assembly drawing. Right, so we have this as our front view, the sectional top view. We also have got that one as a left view. So we can just write here. here at the bottom, half sectional top view. But if you want to be specific, you can write half sectional top view, AA, like that. Right, so that's it for today. I hope you enjoyed this lesson. Let's hope to see you again next time when we look at another big question for assembly drawing or civil drawing in paper 1. Thank you. Good day.